Hi, this is Mr. Prentice here, and today we are looking at energy consumption and the cost associated with running appliances at home, as well as working out the cost of running appliances over a year and so forth. So the first thing that we need to look at with energy consumption is our base unit that we deal with, and that is a watt. So you might have seen some different things, but what we have is our watt is our standard measurement of how much energy an appliance is being used, but we don't generally have a cost associated with watts. What we deal with is we need to be able to convert from wattage. Say a 60 watt light bulb will use 60 watts in an hour, and we need to change that to kilowatts. That's the most common conversion that you'll see through this course. Okay, and just like all of our other prefixes, there is a conversion. A kilowatt is 1000 watts, or if we went the other way, it would be divided by 1000. Yes, there are more. So for example, just like you have a kilogram, there's also like a megagram, which is called a ton we use, or gigagram, there's a gigawatt as well, and terawatt, and so forth. But these are the two that we use. So for example, just say you had a 6000 watt appliance, we never really see that. We actually just call that a 6 kilowatt appliance. So that's probably more like an air conditioner that would use 6 kilowatts. Okay. In the same way, if you had, so just say you had a 4.3 kilowatt air conditioner, then we would know that that's the same as 4,300 watts, because you would times by 1000 to get that. So the first thing that we need to work out is for most of these questions that we will look at is the total energy usage in kilowatts. Actually, in kilowatt hours, the total energy usage in kilowatt hours. So now this is a big thing I've just put down. Lowercase k, capital W, so for watts, and then hours. So this one here, a kilowatt hour, is equivalent to using a kilowatt hour is using 1 kilowatt for 1 hour. This is what electricity companies charge. So for example, I might get charged 30 cents per kilowatt hour on my peak, or at night time I might get charged 9 cents per kilowatt hour for the appliances that are connected to my off-peak meter, so my hot water system, for example. So what we will do for this is work out what we've got. So just say, for example, just say we want to use a 60 watt light bulb for 12 hours. Okay, so this is equivalent, when we say a 60 watt light bulb, what we're saying is it's going to use 60 watts in an hour. So if we times this by 12 hours, we're going to get 60 times 12, which is, where's my calculator? 60 times 12 is 720 watts for an hour. It's equivalent of using 720 watts in 1 hour instead of 60 watts in 12 hours. And then we would divide this by 1000 like we've done here and say that's the same as 0.72 kilowatt hours. Okay, so that's saying if I'm getting charged 30 cents a kilowatt hour, I would get charged 70% of that, so I'll get charged about 20 something cents, maybe about 20 cents or just over. So running this light bulb for 12 hours costs 20 cents. It doesn't seem like that much. However, if you think about if you might leave 10 lights on in the house, 20 cents times 10 is going to cost you $2, and then you might leave those lights on every single day, so you're paying $60 a month for leaving the lights on. EG2, just say we want to find the usage of a 2400 watt say heater. Those little feet heaters are often 2400 watts, and just say we want to run that for say 3 hours and maybe 20 minutes. Okay, that's not 3.2. Okay, so let's go through. I'm just going to go straight away. 2,400 watts is the same as 2.4 kilowatts. Okay, from our earlier conversion, and I have to times this by 3 hours and 20 minutes, which I'm going to put as 3 hours 20 minutes on the calculator. Okay, so my calculator will be 2.4 times 3 hours 20 minutes. Okay, so that's going to use 8 kilowatt hours. So 2.4 times 3 point whatever it was, we use 8 kilowatt hours. Okay. Our next one was EG2. We then want to work out the cost. Is then calculated by multiplying what our total usage was by the amount the electricity company will charge us. Okay, so it's calculated by multiplying by cost from electricity company. Now, I've written an extra E. So, e.g., you get questions like if AGL charge, now usually it's in cents, so usually they'll charge in cents, and you often see things like 32.185 cents per kilowatt hour. That's usually the unit you'll use. Okay, in life I'll see my bill and I see things like that. Okay, so if AGL charge 32.185 cents per kilowatt hour, then we can say find the cost of running, say, 5 40-watt light bulbs for a month. Okay, so I want to leave on 5 40-watt light bulbs for a month. Now, some people do that. Some people leave on their front lights at the front of their house so that, you know, it might look good, or so that they might just like the light, so when they get home late, they can see. So we firstly want to work out what the usage is. So we say our usage is equal to, let's have a look and see what we've got. So we've got 5 light bulbs, and that's times by 40 watts. That's fine. And then that's times by, let's see how many hours there are. There's 24 hours in a day times, well, I said month. So normally with math calculations, a month will be found by multiplying by, say, 365 days in a year, and then divide that by 12 months. Okay, so we can't exactly say it's 30 days in a month, but 365 divided by 12 is about just 30.4 something. Okay, so let's have a look and see. So this gives us 5, I'll put it on the calculator, 5 times 40 times 24 times 365 days a year divided by 12 months. Okay, that's our monthly one. Okay, so that is 146,000 watts is being used for the month, but we want that as kilowatts, so that's going to be 146 hours. This has become watt hours because we've times this by how many hours there are in a month. Okay, so that's hours, and that's times by the watts, so that's why it's watt hours. And now change it to kilowatt hours. So that's our first thing, and then we see our cost, which is equal to 146 kilowatt hours, and we times that by 32.185 cents per kilowatt hour. Now that gives us cents. So I get my answer, so divided by 1,000, so that's kilowatt hours, I times that by 32.185, and that's how many cents, 4699.01 cents is what it would cost us for a month. Of course, there's 100 cents in a dollar, so that's equivalent to $46.99. Okay, so it's actually going to cost $47 to run those 5 lights for a month. Okay, it's why some parents like to say keep turning off the lights and to not use appliances too much. I'll give you one more example. So let's say we're using a EG2. Just say we want to find the cost. We'll say maybe let's make it a bit cheaper. 23.55 cents per kilowatt hour. Okay, so the cost of your fridge running for a year okay, if it uses, let's have a look and see. If it uses, where's my calculator? Maybe it will use 35 watts per hour. Okay, so the cost of running it, of your fridge running for a year, and then I'll just say if it uses 35 watts per hour. I should write if the fridge uses 35 watts per hour. So we would work out what our total usage is. So our total usage, which gives us 35 watts, and then we have to times that by how many hours there are in a year. Okay, so there's 24 hours in the day, and that's times by 365 days in a year. So that's how many hours there are. So that would give us, calculator, 35 times 24 times 365 is 306,600, 306,000 watts. Watt hours? Watts for an hour, that is. as hours, and that's the same as 306.6 kilowatt hours. Okay, that's what it uses in a year. And then we say the cost is equal to 306.6 kilowatt hours times by, what is it, 23.55 cents per kilowatt hour. So we'll times this by, no, I have to divide by 1,000 first to get it into kilowatt hours, and then I'll times that by 23.55 to get us $7,220.43. That's in cents, 7,220 cents, or $72.20 in a year. So the cost of leaving your fridge on costs you, say, $72.20 in a year. Now let's have a look and see if that's actually what happens. So I got, what did I get? 306 kilowatt hours. So let's look up fridge energy consumption and see what it actually is. Obviously, all fridges are different, depending if it's old or new. So an old fridge, a 20-year-old fridge, could use 1,700 kilowatt hours. My calculation was only 300 kilowatt hours. Okay, this is why they're saying, is that an old fridge actually worth keeping? Because a new fridge might pay for itself eventually, because it uses less electricity. Okay, if I look at images, I hopefully will get an energy rating thing. Here's a cheaper fridge, 153 kilowatt hours per year. Now, I don't know what fridge that actually is. It might be a smaller one, but the idea is sometimes people will actually upgrade their fridge, not because they particularly need a new fridge, but because the cost of running the old fridge costs a lot more than the new one. And we could actually do a graph of this. It would look like, I'll show you. So just say we have a cost. So this is my graph, and I'm going to say over time, and then the cost of running. And this is what we sometimes see. The old fridge is more expensive, so the cost of running it over time might look like this. Okay, you're using up the cost over time. If you're running it after a year, it's going to cost this much. After 2 years, it's going to cost that much. Okay, this is the old fridge. Our new fridge, we'll have to go to the shops and buy that new fridge. So it's going to actually start off up here somewhere. You know, it's going to start off higher. However, because the new fridge costs less money over time, what we do is we get a graph that might look like this. Okay, so it costs less money to run because it's using less energy. So this is our new fridge. And what you can then do is work out when this break-even point is. When does the new fridge end up costing the same as the old fridge? Okay, because in this part, the new fridge would have obviously cost more because you just paid it off, or you just paid for it, but eventually it might pay itself off, and then the new fridge is actually going to be cheaper than the old fridge after, say, a few years of running less electricity. Okay, we'll be looking at exercise 4E today. If you had completed that in Miss Wolf's class, then could you please have a look at the level 3 questions, or you can look at the chapter reviews for those students that went from advanced mathematics, so that you could catch up on the missed work. This might also be the last video I make. I've heard that Miss Wolf was taking over making the videos for year 11. I'm not sure if that's been confirmed or not, so you might hear me again or you might not. Okay.